Generations of solar cells. Welcome to Decreations Resources. We have been talking about solar cells, learning about its principle on which it works, etc. And we know now that the primary role of a solar cell or a photovoltaic cell is to receive solar radiation as pure light and transform it into electrical energy, and this transformation takes place by a conversion process which is based on photovoltaic effect. Now, in order to do this, there are several technologies that can be used. These can be used for manufacturing different kinds of solar cells. Now, when you say different technology, there could be material modification that will lead to different photoelectric conversion efficiencies. Now, we can divide these technologies into different generations. As expected, in case of the first generation, basically it contains solar cells based on monocrystalline silicon, polycrystalline silicon, multicrystalline silicon, and even solar cell based on materials like gallium arsenide, which is a 3,5 semiconductor material. You would realize that the generations of various photovoltaic cells basically tell you the story of the stages of their evolution. Now, the next one, that is the second generation solar cells, these are based on thin films. So the earlier one, wafer based technology, the first generation solar cells like monocrystalline solar cells, they were basically thick crystalline films or wafers. Now in the second generation, it's thin film solar cells, and there can be several types like copper indium gallium selenide cells, which are the short form is CIGS, or cadmium telluride cells, which is basically CDTE. Then cadmium sulfide solar cells, CDS, amorphous silicon solar cells, which is usually written as A-silicon symbol, Si, etc. Now the further generations, the higher generations, basically are more of emerging technologies. So they are still majorly in research process. So they contain dye-sensitized solar cells, which are known DSSCs, the short form, quantum dot solar cells, organic solar cells. So there's this whole branch of organic photovoltaics. Then there are perovskite solar cells and concentrated solar cells. Also there can be multiple junction. So there can be tandem solar cells, and there can be hybrid solar cells, which may contain metal nanoparticles, metal oxides, carbon nanotube, graphene, etc. Each generation will have its own advantages and disadvantages, but mostly the main aim for each technology is to acquire as high efficiency as possible and as low cost as possible. Also, one can note here that the higher generation have not replaced the earlier generations. The first generation silicon wafer based solar cells are still existing, and the higher generations are more in the research process. So that is also something to be noted.